Hello friends, in this video we are going to discuss about the position of the Fermi level dependent on the doping concentration in the n-type semiconductor. So let us see how the position of the Fermi level that is EFN will depends on the doping concentration of a n-type material. So, in an n-type material, we know that the doping concentration, this one, is nothing but the donor concentration, that is the ND. Now, let us assume that the doping concentration is high, that is ND is very high, such that ND is greater than the value of NC, and we know that the EFN value is given by EC minus EFN is equals to KT ln NC by ND. Since the ND is greater than NC, so this term ln NC by ND will be a negative value. Since it will have a negative value, so we can say that EC minus EFN will have a negative value. That means EC value is less than the EFN value, and this is happening due to the ND is greater than NC. The physical significance of this equation is that this EFN, that is the Fermi level in this n-type semiconductor where the doping concentration greater than the NC value is now in the conduction band. That's why it is greater than the EC value. So if I draw this inside a band diagram, then it will look like this. So this is the conduction band, and this is the EC value, this is the valence band, and this is the EV energy level. Now, since ND is greater than NC, so we have seen that the EC is less than the EFN. So, the EFN value will be above the EC value. So, let us draw the EFN. It will be somewhere above the EC energy level inside the conduction band, and this is happening due to this ND greater than NC. That means now the Fermi level of this semiconductor n type has moved inside the conduction band. When this is happen, then it is called degenerate semiconductor. So we can define the degenerate semiconductor in the following way. It is a type of semiconductor where the Fermi level will reside inside the conduction band. That's why it is called n-type degenerate. Now this is one type of semiconductor of n-type. Now let us take some cases where the first case is Nc is equals to Nd. Second case, Nd is greater than Nc, and third case, Nd is less than Nc. So for the first case, we can say that ln of Nc by Nd will be 0. That is, the EFN value will be exactly the EC value. That means the EFN position will be at the EC energy level. Now for the second case, when Nd is greater than Nc, we have just derived that ln Nc by Nd will have some negative value. Since this term has some negative value, so we can say that the EFN will be greater than the EC energy level. That's why the EFN has moved inside the conduction band, and we have named the semiconductor as n-type degenerate semiconductor. Similarly, if the Nd value is less than Nc, so we can say that ln of Nc by Nd will be a positive value, which will give that the EFN is less than the EC. That means EFN will lie below the EC, and this type of semiconductor is called n-type non-degenerate semiconductor. So these are the three cases of doping concentration. Now let us draw the three case in a band diagram. So let us take the conduction band in this manner. So this will be the EC, and this is the conduction band CB, and this is the valence band, and this is EV, so it is VB. Now for the first case, Nc equals to Nd, we have EFN equals to EC, so we can draw the EFN like this. The EFN will coincide with the EC value, and this is the EFN for case 1. Now for the case 2, ND is greater than NC, that's why EFN is greater than EC, that is n-type degenerate semiconductor. So for n-type degenerate semiconductor, we can draw the EFN will be above the EC value in the conduction band. So this is the EFN for case 2. Similarly, for the case 3, the EFN value will be below the conduction band somewhere here. So this is the EFN value for the case 3. Now in the case 3, if we decrease the doping concentration, then what will happen? So ND is less than NC, and we are decreasing the doping concentration. So let us see, let us take three values of the doping concentration, ND1, ND2 and ND3, such that ND1 is greater than ND2, ND2 is greater than ND3, and both of them, all of the three are less than NC. Then in the band diagram we can draw, if this is the EC, this is the EV, and if this is the band gap of the n-type semiconductor, then the position of the Fermi level for this ND1, if we denote this as EFN1, for position of Fermi level for ND2 is EFN2, and for ND3 the Fermi level position is FN3, then EF1 will be just below the EC, because EF ND1 is less than NC, so this is EF1, and EF2 will be just below the ND, and EF2 will be just below the EFN1, that is ND2 is less than ND1, so this will be the EFN2 and the EFN3 will be just below the EFN3. So in this way, if we decrease the doping concentration, the Fermi level in the n-type semiconductor is moving towards the middle of the band gap. Now let us denote a equation which will give the shift of the Fermi level with the doping concentration. Let us denote a equation which will give the shift of the Fermi level in the n type for different dopings. So, shift in the Fermi level EFN due to doping with respect to the intrinsic semiconductor Fermi level, that is EFI, or we can say shift in the position of EFN with respect to the middle of the band gap of Eg will be equals to shift Kt into ln Nd by Ni, and the unit of the shift will be in eV, that is electron volt, and this shift will be written as EFN minus EFI, because I am calculating with respect to the intrinsic Fermi level. So, this is all about how the Fermi level position in the n-type semiconductor changes with respect to the doping concentration. Thank you.